journey in stoichiometry. Okay, today we're going to be looking at something called balancing equations, which is very, very, very important to this topic. Okay, there's a number of small parts like we discussed before, very simple to use, but when you put them together, they're very powerful and all very important. Okay, and balancing equations is one of them. Now, in balancing equations, what are we trying to do? We are trying to support the law of conservation of matter or mass, right? And we should be familiar with that, but I'll write it down, okay? It says that matter, okay, cannot be created or destroyed. Okay, so matter cannot be created or destroyed. So we want to support that. And how do we support that? With the fact that we want to make sure that we have the same number of atoms on both sides of the equation, the chemical equation. Now remember guys, okay, the chemical equation, okay, has a reactant side to it. So put a reactant side right there. And once again guys, your definitions are very important. So these are your reactants to the left of this arrow right here, and these are your products, product side, okay. There's one product right here, NH3. Okay, and this arrow means to create, to make, or to yield, or produce, right? So know your definitions, know what things mean, okay? So our goal in life in balancing equations is to make sure that the number of atoms on this side equals the number of atoms on that side. Your reactant side number of atoms equals the number of product side number of atoms. It doesn't have to be molecules, guys, but number of atoms, it must be the same number on both sides. Okay, so we're going to move over here. Right. Now over here, so you guys can see, all right, we have an equation right here. We have hydrogen plus oxygen, right, reacting to give you water, H2O. Now this equation, guys, is not balanced, right? So we're going to attempt to balance it. So what do we want to do? We want to use the C word. We want to use, guys, something called coefficients. Coefficients, right? To make sure our equation is balanced. And from math, right, we know that coefficients always, always, always go in front. You cannot put them in the back. You cannot put them in the middle of a compound. You must put them in front. Anywhere else is a major violation, right? So we will put coefficients in front. Now, as I always say with this topic of balancing equations, I tell my students, use trial and error, okay? Meaning, let's say you're doing a balancing equation, you put your coefficients in, and let's say you fix one element, but another element gets messed up with the coefficient. You don't panic, you change it, you try again, okay? You check your numbers, all right? So this guy right here, the balancing equation, what I like about it, you know if you're right or wrong when you're finished, because if your numbers on both sides in terms of atoms are not equal, something's wrong and you're able to fix it, right? No problem. Okay, so we have this guy, H2 plus O2 giving it H2O. So normally when we're starting out, we tend to make a little chart, right? So we're going to put hydrogen there, okay? Because we have hydrogen, so we have oxygen. So those are our elements in this particular problem, right? So we'll put a line right here. I'm going to indicate that this is my reactant side, okay? And this side over here is my product side. And all we're doing, guys, we are counting, all right? Number of atoms on this side in terms of an element, number of elements on that side, do they match up? If they don't match up, we fix it. If they do match up, we leave it for now, okay? So that's what we're doing. All right, so for hydrogens, right, we notice we have two hydrogens right here. We notice we have two hydrogens right there, okay? So the number of atoms for hydrogens, okay, on both sides, right? No problem. If we look over here on this reactant side, right? The reactant side, we got two oxygens. So you're gonna put a big two right here, bam, two, right? We look on this side, our product side, okay? Look at oxygen. How many oxygens you got? We have only one. Now guys, important. If you don't see a subscript, it means one. If you don't see a coefficient in front, it means one also, because we don't show the number ones typically in chemistry, right? No problem. So we have only one oxygen. So we have to fix that situation, okay? We have to fix that situation. So here's the deal, guys. If you got 2 right here and only 1 there, what we do, we have to use a coefficient, people. All right? You cannot change this to a 2 to balance the oxygens. It's a violation, right? We got to use coefficients. So we're going to put a big 2 in front here. Bam. Okay? So what does that do for us? This 2 distributes right through it. It distributes to the H and the O. So now we can change this to 2, because now we have 2 oxygens. 2 times 1 is 2, right? Our oxygens are okay. But let's check our hydrogens. Here we have 2 hydrogens, as before, no problem, right? But what happens here now? What's 2 times 2? 2 times 2 is 4, right? So now we have 4 hydrogens there, and only 2 there. Well, like I said before, trial and error. You don't panic. You fix this guy, okay? So we're going to put a 2 right here. Now we have 4, okay? So now we have 4 for hydrogens. We got 2 for oxygens. The equation is now balanced. But ladies and gentlemen, here's the deal. I think of this chart, right, like training wheels, okay? We're using it to get our equilibrium, to get our balance, okay? So what I did there, okay? Now, we don't need the chart anymore because we know the technique, right? So now we're taking the training wheels off. We're not going to use charts to solve these other guys, all right? But we will definitely use a technique of counting how many atoms on both sides, okay? So here we go. So this guy right here is N2 plus H2. Now, this means, well, it means reacting with H2 to produce NH3, right? So we do some analysis. We got 2 N's right here. We got only 1 there. We're going to fix that. We're going to put a big 2 in front here. Bam. All right? That now gives us 2 nitrogens on both sides. 2 there and 2 there. But remember, this 2 coefficient, right, distributes right through, okay? So it goes right through. It goes to the N and to the H, right? So now we have 2 times this 3 right here. You guys can see that? 2 times 3 is 6. We have 6 hydrogens, okay? Now, if we have 6 hydrogens on this side and only 2 on this side, what do you think we're going to do? Okay? We're going to put a 3 here, all right? 3 times 2 is 6. 2 times 3 is 6. Hydrogens are okay. Nitrogens are okay. 2 H's right here. Oh, goodness, I put it in the wrong place. Oh, goodness. All right, here we go. 2 times 3 is 6. 3 times 2 is 6. Hydrogens are okay. Okay, made a mistake. I'm human. All right. 2 N's right here. 2 N's right there. You're done. Okay, cool. Moving on. All righty. We got KClO3 right here, folks. Decomposing, breaking down to give you KCl and O2. Now, ladies and gentlemen, in life, in chemistry especially, we like to work with sort of kind of even numbers to make our life simple, yes? So if we have 3 oxygens there and only 2 there, we don't panic, right? There's a simple way to fix that, all right? But let's check our K's. We got K here, we got K there. Our potassiums are okay, all right? We got Cl here, we got Cl there, 1 and 1. The Cl's are okay. So the issue now is with the oxygens. We got 3 oxygens here and only 2 there, okay? So what we can do, we can find a common multiple for them, right? So if we say, okay, common multiple, simple common multiple for 3 and 2 is 6, right? How do I make this guy 6? All right, I got 2 already. I can put a 3 there. 3 times 2 is 6, all right? Okay. Now, how do I make this 6? I'm going to put a coefficient in front for 2, right? 2. 2 times 3 is 6. So now I got 6 oxygens here. 2 times 3 and 3 times 2. My oxygens are okay, all right? But now we're going to check the K's and the Cl's. Remember, this 2 distributes right through, right? So now we have 2 K's, we got 2 Cl's. We have only 1 K and 1 Cl. We're not going to panic. We're going to use coefficients to fix it. So we're going to put a 2 in front here, okay? So now we got 2 K's, 2 K's, 2 Cl's, 2 Cl's, 6 O's, and 6 O's. The equation now is balanced, okay? So once again, guys, keep using trial and error. Look at it carefully. And the thing is, like I said before, if the numbers are not the same on both sides, you know you made a mistake, you fix it, no problem, all right? You're in control. guys can see this. When we're looking up here, folks, we got AgNO3 reacting with MgCl2, magnesium chloride, giving us AgCl and MgNO3, magnesium nitrate, right? So this is a double replacement reaction, which we talked about before, okay? No problem. We're gonna balance this guy. Now notice, right, we have an NO3 right here. Now this is a little trick, a little shortcut, if you will, right? Where you have NO3, so rather than separating it into N's and O's, right? We know from experience as a polyatomic ion, it's found on table E, okay? Now the thing is, if you have the same polyatomic ion on the other side, you can treat it as a unit, okay, instead of breaking it apart, all right? That's only if it's on both sides, okay? Same polyatomic ion. So I have one NO3 right here. On this side, if you can see it or not, I have two NO3s. So what am I gonna do? I'm gonna put a 2 in front here, bam, okay? So now I have 2 NO3s on this side, and I already have 2 NO3s there. I just fixed my NO3s, okay? So NO3s, nitrates are okay. Now I have 2 what? I have 2 Ags, 2 silvers, right? I only have 1 silver there. So what do you do? What do you do? You simply put a 2 here. Remember, we are using trial and error, right? We're now analyzing the situation. We got 2 Ags right here now. We have 2 Ags right there. So Ags are okay. The nitrates are okay. All right, so let's check the other guys. We have 1 Mg here. We have 1 Mg there. So the Mg's, magnesiums are okay. We just so happen to have 2 Cl's right there. And we have 2 Cl's right there. The chlorines are okay. This equation is balanced. You're done. You move on. Okay, no stress. All right. So we have this reaction right here. We have C3H8, propane, right? We'll learn that in organic chemistry later on, so no panic. Reacting with oxygen to give you carbon dioxide and water, okay? Classic combustion reaction, no problem. So we're gonna balance this guy. So I tell my students always, right, when you have a combustion reaction like this, start with the carbons and the hydrogens and fix the oxygens last, all right? So we have 3 carbons right here, so we're gonna put a big 3 right there, bam. Okay, so now we have 3 carbons there and 3 carbons there. Our carbons are okay, right? Let's check our hydrogens. We got 8 hydrogens here, yes? All right, so we only have what? We only have 2 there, so you put a 4 there. 4 times 2 is 8, right? Okay, take a breath. We successfully balanced our carbons. We successfully balanced our hydrogens. But what do we have left? We have oxygens. We got 2 oxygens on this side, but on this side we have to be very, very careful because we have 3 times 2, right? 3 times 2. We have 6 oxygens here in the carbon dioxide, but we also have oxygens in the water. We got 4 times 1, so we got 4 oxygens in the water. See that? 4 times 1 and 3 times 2. So guys, we have to account for all the oxygens, yes? So 6 plus 4 will give us a total of 10 oxygens on the product side. So if this side, product side, has 10 oxygens, right guys? And there's only 2 there, what do you do? What do you do? How do you get 10 on both sides? Okay, we're gonna put a coefficient of 5 in front of this guy. 5 times 2 is 10. You're good to go. You check it again, no problem. The carbons, the hydrogens, the oxygens are okay. Excellent, you move on. Okay, get this guy right here. This is another combustion reaction, right? But this guy has an odd number for the carbon. This guy has an even number for the carbon, right? So it should work out. Let's see what happens. Okay. So carbons, how many we got? We got 6, right? Okay. So you're going to put a 6 there. Bam. All right. So we got 6 carbons, 6 carbons. Hydrogens, how many we have here? We got 14 hydrogens, right? So we're going to put a 7 in front here. 7 times 2 to make that 14. So our carbons are okay. Our hydrogens are okay. Let's fix the oxygens, all right? So, we got 2 oxygens right here, no problem. Now here, remember, we have 2 sets of oxygens. We have to account for all of them, right? So what's 6 times 2? 6 times 2 is 12, okay, bam. And what's 7 times 1? 7 times 1 is 7, right? Bam. Now we have 12 oxygens plus 7 oxygens. 12 plus 7 is what? 12 plus 7 is 19 oxygens. And here's where students start to scream and holler, right? Oh my goodness, how are we going to make this 19, right? Because it's an odd number, yes? Okay, you don't panic, okay? You simply ask yourself, what times 2 gives you 19? Huh? Okay, so it'll be half of this guy right here, okay? So that will be what, 9.5, if I'm not mistaken? Okay, so 9.5, okay, we'll go there. But we have to establish a fact, right? Well, we typically don't leave our coefficients as decimals, right, guys? So what we do, we don't panic, we're going to multiply this 9.5 by 2. But remember, from math, right, if you do one thing to one variable, you have to do the same thing to all the variables, right? So if we're multiplying this 2 by 9.5, okay, we have to multiply this by 2. We're going to multiply that coefficient by 2. We have to multiply that coefficient by 2, okay? You can either put a bracket and multiply the whole thing by 2 or just do what I did here, no problem. So let's write the coefficients in for the final answer. So 2 times 1 is 2. So I'm going to put a box right here. So 2 goes there. Okay, that's our final coefficient for the answer, yes? This was originally 9.5, but since we agreed we got to multiply by 2, 2 times 9.5 is 19. So put a box right there, so the final coefficient for there is 19. Over here, right, we had 6 originally, right? We're going to multiply by 2, yes? So we're going to change that to 12, okay? And here we originally had 7, but we're going to change that to what? To 14, okay, to make sure that everything got properly multiplied by 2. And that should be okay. So notice we got 2 times 6 is 12. We got 12 oxygens. We have 2 times 14, that's 28 hydrogens. 14 times 2, that's 28 hydrogens, okay? 2 times 19 is 38, okay? And 12 times 2 is 24. And 24 plus 14 is 38. All the atoms are balanced, okay, guys? So that's a nice, wrap up for this balancing equations. Remember, guys, use trial and error. Don't make up stuff. Use coefficients in the right place. If it needs a coefficient, put it. If you don't need a coefficient, don't force a situation. It is what it is, okay? As always, hard work plus sacrifice equals success. Keep studying, guys. Do well. All right, take care.